So we're going to learn today how to write formulas and names for covalent compounds. So covalent compounds are going to be a little bit different than ionic compounds. When you look at the three I have here, you should start to see some patterns. We're going to talk about how you know it's a covalent compound and the patterns that we see. So one of the first things you have to be able to recognize is if you have an ionic compound, which is what we've been working on, or if you have a covalent compound. So how do you know if something is covalent? Covalent compounds are where the atoms are going to be sharing their electrons. And so this is going to happen when we have two nonmetals. So we want to remember that the nonmetals are located to the right of the periodic table zigzag line that divides our metals and nonmetals by the transition metals. So first thing you should recognize is that, okay, I have two nonmetals, which means that we are going to have a covalent compound where the elements are going to share electrons. So we don't have to do anything with charges. We don't have to worry about a positively charged ion and a negatively charged ion. There's none of that. All we have to do is we have to look at how many of each element do we have, and we use prefixes. So if we take a look at the examples I have here, NO is nitrogen monoxide. I have one nitrogen atom, so I just call it nitrogen. I have one oxygen atom, so I put a prefix of mono, and then I'm still changing the ending to IDE on the second element, just like we did with all of the other compounds. If you look at the next one, NO2. Now, ignore my typing on these slides. That should be a subscript of 2, not a full-size 2 like that, but because it's a PowerPoint slide, it didn't quite come out right. So that would be nitrogen dioxide. So again, I'm naming my first element and I'm putting a prefix. The prefix of di means that I have 2 of those oxygens. Then on the next one, notice that the 2 is on the nitrogen. So I've got N2O. That's called dinitrogen monoxide. So when I have 2 nitrogens, I put the prefix di on the nitrogen. I've got 1 oxygen, so again, mono means 1, so that's going to be monoxide. If I look at the next one, N2O4, I have dinitrogen tetraoxide. So the di tells me I've got 2 nitrogens, and the tetra tells me I have 4 oxygens. And then the last one, we've got dinitrogen pentaoxide. So again, the di tells me I have 2 nitrogens, and the pentaoxide tells me that I have 5 oxygens. So here's our steps and our guide for doing 2 nonmetals, which is going to be a covalent compound. You're going to name the nonmetal first. So just like in an ionic compound where we named the metal first, we're going to name the nonmetal first. Then what we're going to do is we're going to name the second nonmetal. We're going to change the ending to IDE. So same thing that we did with ionic compounds. Nothing's changed still. The only difference is in step 3, we're going to add prefixes. So depending on the number of each element we have, we're going to add a prefix in front of each of the elements' names. So when we add the prefixes, we will use mono only on the second element. If we have one of the first element, we're not going to put the prefix mono. We're just going to say nitrogen, or we're just going to say carbon. So when you hear things like carbon dioxide, carbon, we didn't put the mono in front. We've got 1 carbon. Nitrogen monoxide. Nitrogen, have 1 of them. We didn't put the mono in front. But you can hear with carbon dioxide, you hear that prefix on the second element of oxygen. Nitrogen monoxide, we hear that prefix on the second element. So these are the prefixes that are used. You're going to basically just need to memorize them. For mono, that's 1, di is 2, tri is 3, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And you just have to memorize those prefixes. Hopefully, some of them you are familiar with. Tri, 3, tetris, tetra, 4. So you'll have to memorize those prefixes that are being used. All right, so the first one to try. We have SO3, and I do apologize. Again, I'll fix it It shouldn't be SO with a large 3, it should be a subscript of 3. But we're gonna name S, sulfur. We're gonna change oxygen to oxide. So we've got sulfur and oxide. And then we're not gonna put the prefix of mono on the sulfur because it's the first one. We're just gonna understand that we just have one of them for that first one. And then since we have 3 oxygens, we're gonna put the prefix of tri. So SO3 would be called sulfur trioxide. All right, here's another practice for you, P4S3. So we're gonna name the first non-metal, P, phosphorus. We're gonna change sulfur to sulfide, and then we're gonna put in our prefixes. So we have 4 phosphorus, so we're gonna put tetraphosphorus, and we have 3 sulfides, so we're gonna do trisulfide. So P4S3 would be tetraphosphorus trisulfide. Covalent compounds are often used in everyday products, so here's a list for you of some very common covalent compounds. You're probably familiar with carbon dioxide, as well as familiar with nitrogen oxide and nitrogen dinitrogen oxide. Those are all things that are used commonly in everyday products of ours. So here's the rule. We look to have 2 nonmetals. The first nonmetal, we only use a prefix if it's not mono, and the second nonmetal, we use whatever prefix we need to according to the number, and we change the ending to IDE just like we did in the previous ionic compounds. So what I'd like you to do is take a second, read through each of these, and see if you can select the correct name for each compound. We have SiCl4. Your choices are silicon chloride, tetrasilicon chloride, or silicon tetrachloride. Letter B, we have P2O5. Your choices are phosphorus oxide, phosphorus pentaoxide, or diphosphorus pentaoxide. And then for letter C, we have Cl2O7. Your choices are dichlorine heptaoxide, dichlorine oxide, and chlorine heptaoxide. See if you can pick out the correct ones for each of these. So hopefully you got all 3 of them correct. The first one should be silicon tetrachloride. The second one should be diphosphorus pentaoxide. And the last one would be dichlorine heptaoxide. So again, see if you can write the names of each of these covalent compounds correctly. CO, remember we're gonna name the first one. We don't put a prefix unless it's more than 1. And then we're going to change the ending of the second nonmetal to end in IDE, and we're always gonna put a prefix on the second one. So take a minute, see if you can write the correct name for CO, for CO2, for PCl3, CCl4, and N2O. So pause the video for a second if you're not finished. Take a minute, try to go back, look at those prefixes, and determine what the correct covalent name would be. Hopefully you got these all right. Carbon monoxide, we're gonna name the first one carbon. We're gonna put the prefix mono because we just have 1 oxygen. For carbon dioxide, we're gonna name that first metal, or non-metal, sorry, carbon, non-metal, and then we're gonna put di on the prefix before oxide because we've got 2 oxygens. Phosphorus, we just have 1 of them, no mono, we just name it phosphorus. And then chlorine, we have 3 of them. So we're gonna put the prefix of tri, and then chloride, because we're still changing that ending to the IDE. CCl4, we're gonna name the carbon, then we're gonna put the tetra in front of the chloride to show that we need 4 chlorines. So, and we're still gonna change that ending to the IDE, so carbon tetrachloride. And then N2O, we have 2 nitrogens, so we do need a prefix on that. So we're gonna put dinitrogen, and then oxygen, we always put the prefix on the second nonmetal. Since we just have 1 of them, we're gonna put that prefix of mono. So what happens if we are given a formula or a name and we have to write the formula? So we're gonna write the symbols in the order that we're given, and then whatever prefix, we're gonna put that as the subscript, because remember the prefix tells us the number of each of those different elements that we need. So if I have to write the formula for carbon disulfide, I can first recognize my two elements. Carbon is C and sulfide is sulfur, so S. Now there's no prefix on the carbon, so we just have one of them, but we do have a prefix of di on the sulfur. So that's actually telling us that we have two of the sulfur. So we're gonna need to put a subscript of 2 for that sulfur to show, okay, that's why we have the di. The di is telling me we have 2 of them. So let's see if we can write the correct formula. Phosphorus. First thing, what's the symbol? The symbol for phosphorus is P. Pentachloride. So chloride is chlorine. We know that the symbol for chlorine is a capital C and a lowercase l. Now we look at our prefixes. No prefix on phosphorus, so we just have one of them. We have pentachloride. Penta is the prefix for 5, so that tells us we have 5 chlorines. Letter B, dinitrogen. Nitrogen is the letter N. Trioxide. Oxygen is the letter O. Then we look at our prefixes. Dinitrogen tells us that we have 2 nitrogens. Trioxide tells us that we have 3 oxygens. And then finally, we have sulfur hexafluoride. Sulfur is a capital S, fluorine is a capital F. And then again, we look at the prefixes. There's no prefix on sulfur, so that means we just have one of them. And then hexa, this might be one that you have to memorize and remember, but hexa is one of those prefixes that might be a little bit more difficult for you to catch on to, and that you might have to just memorize. So for each of these, we got PCl5, N2O3, and SF6. All right, so this one is a little tricky. There are both ionic and covalent compounds on here. So remember, an ionic compound is a metal with a nonmetal. So you're gonna have an element on the left side of the periodic table with an element on the right side of the periodic table. If it's covalent, then it's gonna be 2 elements over on the right side of the periodic table. So those are gonna be 2 nonmetals. So I'm gonna start with just identifying ionic or covalent. So SO2, find sulfur, find oxygen. You're gonna notice they are both on the right side of our periodic table. Nonmetals, covalent compound for letter A. Letter B, barium is on the left side, chlorine is on the right side, ionic compound. Letter C, polyatomic ions. Polyatomic ions are always ionic. We know polyatomic ions are on the back of our periodic table, that they've got special names to them. That's ionic for letter C. Letter D, right away, copper. Hopefully you know copper, metal. As a matter of fact, hopefully you're thinking transition metal. I'm gonna need Roman numerals with the name. And then we also see CO3. Oh, polyatomic ion. Ion, ionic, okay? Now letter E, we've got nitrogen, find it on your periodic table. Oxygen, find it on your periodic table. You'll notice they're both on the right side of the periodic table. 2 nonmetals, covalent compound. Go ahead, take a minute, pause the video, see if you can name each of these compounds with their correct names, now that you know if you're naming it as an ionic compound or if you're naming it as a covalent compound. So here we go, let's see how our names came out. So A is covalent, so we name sulfur. Oxygen gets the prefix, 2 oxygens, so sulfur dioxide. Letter B, ionic. We name the metal, barium. We change chlorine to chloride. We're done, barium chloride. Ionic compound with 2 polyatomic ions. We never change the name of the polyatomic ions. NH4 on the back of your periodic table is called ammonium. PO3 is called phosphite. Ammonium phosphite. We leave it as it is. Now letter D does include a transition metal, so we've got to figure out what kind of charge copper has on it. So if we look at the back of the periodic table and we see CO3, It's called carbonate. We see it has a -1 charge. Because our formula has, a -2 charge. Because our formula of copper has 2 coppers, we're going to have to balance with that -2 charge. Each of those coppers are going to have a +1 charge. So that's how I figured out it's copper 1 carbonate. So we got to go back to those rules. When we've got a transition metal, we look at the negative ion, we figure out the charge on the negative ion, and then we look at how many of the positive ion we have so that we can figure out the charge of the positive ion. And then letter E is covalent. So we name the nitrogen, we change the name of the oxygen to oxide, and we put our prefixes in. So we've got 2 nitrogens, we're gonna say dinitrogen. We've got 4 oxygens, we're gonna say tetraoxide. So we're gonna name these compounds. First thing, determine if it is ionic or covalent. So if we look at letter A, we've got calcium, that's a metal. Right away, it's ionic. Letter B, iron, metal, transition metal. We're going to be using Roman numerals in the name. Letter C, S, sulfur. Sulfur is on the right side of the periodic table. Covalent compound, 2 nonmetals. Letter D, chlorine and oxygen. Again, both chlorine and oxygen are on the right side of the periodic table. So 2 nonmetals, so covalent. So C and D are going to use our prefixes, while A and B are going to be ionic compounds. We name the metal, we change the ending of the nonmetal to IDE, or we name the polyatomic ion. So take a minute and see if you can name A, B, C, and D. So letter A would be calcium phosphate. Letter B would be iron 3 bromide. Again, remember when we have a transition metal, we have to look at the nonmetal. Bromine gets a -1 charge to it. We have 3 of them, so the total negative charge is -3. We only have 1 iron ion, so that 1 iron ion must get a +3 to balance with that total -3 charge coming from the bromine. So that's how I got the iron 3 bromide. Letter C and D, we use the prefixes. Sulfur dichloride, and then dichlorine, that should be monoxide. So next we have to practice writing the formulas. So calcium nitrate. Notice that nitrate, polyatomic ion. Look on the back of your periodic table. Ionic compound, you're gonna make sure the charges are 0. Letter B, boron trifluoride. No charges. Boron and fluorine are both nonmetals. We use the prefixes, no charges. Letter C, aluminum carbonate. We have to figure out the charges. We have to make sure the charge equals 0. Letter D, dinitrogen tetraoxide. Prefixes, 2 nonmetals. We don't have to worry about any charges for letter D. We just write the formula from the prefixes given to us. Letter E, copper 1. Remember the 1 tells us the charge. We're gonna have to look at phosphate on the back of the periodic table, figure out its symbol, figure out its charge, put it together to make sure there is no charge. So take a minute, see if you can write the correct formulas for A, B, C, D, and E. So here's our solutions. Calcium gets a +2 charge. Nitrate is NO3 with a negative charge. We're gonna need 2 of the nitrates, so we're gonna put parentheses around that polyatomic ion, and then we're gonna put a 2 after it. Boron trifluoride, no charges, BF3. 1 boron, no prefix on it, trifluoride, 3 fluorides. Aluminum carbonate, aluminum gets a +3 charge, carbonate gets a -2 charge. So we're gonna need to get an overall charge of a +6, so we're gonna need 2 aluminums. We're gonna need a -6 to balance that to 0, so CO3 is going to need 3 of those. So we're gonna need to put parentheses around it and then put a 3 underneath as that subscript. Letter D, dinitrogen, 2 nitrogens, N2. Tetraoxide, 4 oxygens, O4. And then letter E, copper 1, gets a +1 charge on the copper. Phosphate is PO4 with a -3 charge. So that means we're gonna need 3 coppers in order to balance with that -3 charge coming from the phosphate.